Okay, good afternoon, everyone. Welcome to this, the third large systems session of the day. This is session 9E, where we've got Rob Scott from Rocket Software taking us through SDSF Security. How does it work on zOS 2.5? Please feel free to post questions in the chat as we go, and I'll look for opportune moments where I can interrupt Rob and ask. With that, Rob, over to you.
Thanks, Joe. Okay, my name's Rob Scott. I've been at Rocket for around about 20 years now. And for the last 7 years or so, one of my responsibilities is to be an architect and developer for SDSF on behalf of IBM. And I've decided to give this presentation again because we are seeing a few customer calls coming in about SDSF security on 2.5. I think with 2.3 going out of service, it's forcing the hand of various customers to actually consider their migration to a more recent release of zOS. And one of the things that they have to do is contemplate the security migration to SDSF using SAF. So this is the reason I'm going to give this presentation again. Okay, so this is the agenda, what we're going to talk about. A bit of background about why we've removed the internal security in 2.5. Going over some fundamentals of how SDSF works and how we set up our security environment and what our expectations are once a user tries to use the software. Go through basic usage of SDSF panels and what happens. And more importantly, what happens when you try and do something more aggressive, like you could take an action, you're doing an overtype against a row on one of our tables. A little bit more interesting about controlling the scope of the data that the users can see. And then we get into some more sort of advanced functions, looking at foreign address spaces, issuing operator commands and things like that. And then a little bit of guidance really on how you can use SDSF itself to understand the SDSF security and how we do things. And there's some helpful tips there to help you debug your own security issues and prevent you having to call IBM to report a problem. Okay. So a bit of background. So historically, SDSF had some internal security tables. In the very, very old releases of SDSF, it was a assembler source called ISF Palms that you filled in a load of macro keywords and you generated, you did an assembler and link edit and you generated a load module, and then that was made available to the client programs, the client users of the software, and that had configuration statements and security statements. Around about the 1980s, there was an alternative to that, which was ISF PRM-XX, member of the Palm concatenation. So that was basically taking all those old style assembler keywords and making it a bit more user-friendly and a member of Palmlib, and we could do refreshes and things like that. And then there was a very easy conversion from the old assembler source to that ISF PRM. There was like a tool that you could run. It would generate you your first ISF PRM-XX, and it was pretty accurate. Around about the end of the early 1990s, we introduced SAF security into the product. And we have been strongly advising customers migrate to SDSF SAF security for at least 25 years. So when Rocket got divested the responsibility for SDSF, one of my initial goals was to enforce this. I think IBM have been too nice to you guys for too long, and I'm prepared to be not so nice and force you all to use SAF. And one of the reasons for doing this, of course, is that having products internal tables to do security is very old school. It's very 1990s, 1980s. And these days, with all the regulations, we want central auditing, central administration. So you really do need to be putting your security decisions through your security product that you've paid a lot of money for. Anyway, so SDSF 2.4 and below, we always attempted to call SAF first. So we'll do the SAF call, And if we get a no decision back from SAF, which means that SAF could not make a decision for some reason, we would fall back to what you specified in either your ISF PRM-XX Palm member or your old ISF Palms load module. But in 2.5 onwards, we now only do security checks via SAF. And these security checks are actually done by code in the SDSF server address space on behalf of the user. We do load in 2.5 an emergency fallback version of ISF Palms in case your initial ISF PRM-XX fails to activate. So we expect to be able to activate our parameters ISF PRM-XX at server startup. If we can't do that, we will fall back to the load modules, but we will not fall back to your client ISF Palms for security decisions. So your ISF Palms load module that's available to your TSO ISGF users, we never reference that at all. If we do have some sort of activation problem for the server, we still allow systems programmers or permitted people to use the product, but you've got to have permissions to this server.nopalm resource in the SDSF class in order to do that. So general users will not normally have access to that. So we provide that so you can fix the issue and reactivate and then make the product generally available to all users. Okay, some security fundamentals of how we use SAF and how the checks are made. So, as I said before, SAF security is required and mandatory starting from zOS 2.5. We did write a new manual, a security migration guide, because this is a non-trivial project to convert from the old internal security to doing SAF. We do provide a couple of tools. There's a tool called ISF ACR that was written 25 years ago, but they're not a one-stop shop. They are not accurate. They are purely just a starting point to help you generate your first efforts at seeing what sort of things you're going to have to do. It was never the intention to run this tool, run what it produces, and then you're done. Wash your hands and you're done. That is not the case. So you're going to need some sort of iterative process with extensive testing and validation of what this tool throws out. And unfortunately, the difficulty rises exponentially if you have not already activated your JESPOL class. That in itself is an enormous project. If you have not got JESPOL active, activating that class and getting all your profiles accurate to protect your sysout is a big project. And bear in mind that the SDSF security for access to output, if JESPOL class is not active, is just within the SDSF product. There are other software products on your system that regularly process sysout. And so JESPOL is a big thing. Now, we did realize that there's some limitations with the old ISF ACR tool. It's a bit cumbersome. It was written a long time ago, so it wasn't really expecting the sort of size of security environments that some customers have. So we've recently closed an APAR PH49811 that's added this tiny little aid called ISF NTCNV, which aids conversions of if you use ntables, NTBL, NTBLN statements in ISF PRM to sort of declare groups of jobs or user IDs. This tool looks at those and attempts to generate appropriate or sample RACF statements to either define JESPOL profiles based upon them or to do connections to a RACF group based on user IDs and stuff. So that's a nice lightweight tool. It's very simple. It doesn't care about how big your RACF database is. You can just run it iteratively, and it's pretty good. Okay, there is also all the security documentation is in our operation and customization manual, and it's a large amount of tables. There's a lot of profiles that we do use internally for the SDSF class security and the JESPOL and upper commands classes that we call as well. So you will need the SDSF class needs to be active to protect SDSF resources and our own product functionality. And this includes abilities to show the SDSF panels and to take actions against objects shown on rows. And we will also do other SAF checks, other classes such as JESPOL and upper commands as a courtesy and as a way of improving the user experience. But we don't own the resources behind it. We don't own the sysout JESPOL class profiles. We don't own the operator commands that we might be trying to issue. So we're trying to do when we do these calls to JESPOL and upper commands, we're trying to give you a nice message back if you've not got access and things like that. When the resultant thing happens, maybe you do an action against a row on an SDSF panel, it generates an upper command. Even if if you say, yeah, okay, you're good to go, the BCP component that receives that command will make that SAF check independently of us. Okay? So there is a little bit of value add that we do at the same time. So a good example of this is user ID tries to cancel some output. Okay? So if you just issue the JES command natively, there's an upper commands profile, JES.cancel.bat or whatever. But if you're using it via the SDSF product, if you're using that action character, we actually do an extra SAF check for auto access against the JESPOL profile that covers that output. This is like a nice thing. It's a value add for our product. It doesn't necessarily happen if you issue the command natively. So let's continue. The SDSF server address space. So obviously, we're doing the security checks from code in the SDSF server address space. So the SDSF server is mandatory from zOS 2.5 onwards. The SDSF server address space is a resource owning and service owning address space. It doesn't do data collection. So unless you're installing maintenance, there's absolutely no need to restart it after an IPL. It comes up, the SDSF address space exists. You don't have to worry about it ever again. We do use another address space called SDSF Orcs, and that is the guy that does occasional data collection. And we use that guy for sysplex communication as well. And that can be stopped and started independently of the SDSF server address space. You can leave the SDSF server address space up, and you can just do a modified command to SDSF to stop and start Orcs if you have to for whatever reason. These guys will need an entry in the starter class for each of the server address spaces, and you will need an OMVS segment for the user ID associated with SDSF Orcs, because we do some Unix style data collection services within that address space. And we also need some read access to some facility class profiles. We do an extract of the WM policy. We call RMF for various bits and bobs of performance data. So you will need access to those two as well in the server. When the user connects to SDSF, you must connect to the SDSF server in order to use the product. And we only allow one connection per task or TCB. And your ability to use the product, i.e. connect to it, is protected by an SDSF class profile isf.connect.sysname. And if you don't have read access to that profile, you will not be able to use the product. What happens after you connect is that the server will attempt to place you into an SDSF group. Now, in the past, an SDSF group would contain customization options, and still does, but it would also control in the non-SAF security definitions. That is no longer the case. Groups in SDSF now pretty much are just for options and customization settings. So what we'll do when the user attempts to connect, we will go through the groups in order in ISF PRM XX, and we'll try and assign you a group based on read access to a SAF profile, group.name.sysname. And if you pass that, if you get read access to that group, we will put you into that group. So you'll get into the first group specified in ISF PRM. If we can't map you to a group, then the connection will fail. So a little bit about basic channel usage now. SDSF users, we sort of think of our SDSF users in three broad groups, we've got the systems programmer or the technical administrator. We've got operators, and then we have what we call our general users. A good example of that would be just a COBOL programmer. And typically the general users only care about seeing their job and their output inside the product, and they have a limited set of functionality within SDSF. We do supply a sample ISF PRM 00 member in our SISF JCL dataset, and that's pretty much sufficient for most installations. But we also provide ISF PRM 01, where we supply all the default values for all of the statements. It's a much larger. I would recommend you look at ISF PRM 00 and aim to be as brief as you can. Access to SDSF panels. So general user panels, as I said before, this COBOL guy who's compiling his COBOL program and doing a link edit, and he wants to see his output. In order for him to see the SDSF panels that are involved, what we call the Q panels, which is H and O and I and ST and things like that, he needs read access to an SDSF class profile. And the format of that is isfcmd.dsp.name.qualifier. Okay? And DSP, think of that DSP second qualifier standing for a display. The systems programmer and operator panels are protected by a second set of profiles, and their second qualifier there is odsp.name.qualifier. Okay, so think of ODSP as being operator display. So general users can easily be denied access to the advanced displays by having no access none, to isf command.odsp.*. And as far as they're concerned, if you do that, then they're just going to see the same old 5 to 8 choices that they've seen for many, many years, and they will not see the 60 or 70 or 80 rows on the main panel that operators and systems programmers will see. You can issue a set command, set menu all, and that will show you all of the entries on the panel, no matter if you have access to them, but it will tell you why you can't normally see them, like it's the JES3 or you don't have access. But the display pull downs in the CUA action bars, they will always show all of the panels, but they'll be graded. Okay, so the other thing that you're going to do in the product is you're going to type an action in the NP column against a row on an SDSF panel. So normally you need sort of read access against that object for display style actions, but you might need higher access, update, control, or alter for change and delete style actions. When that action character that you type just displays another SDSF panel, then we typically don't have to do any further row object access, because the data collection on the launched panel will have its own command access check. We do some checks, as I said before, on JES class profiles for active jobs and outputs. So rows on ST, DA, HI, and O. We will check the JES profile. So if you try and browse a job with an S, we're going to make under the covers a JES class profile check for read access to that. Certain panels will have other classes and resources that we check as well. And a good example here is the X-Facilic class for the health check rows. Okay, so there's an X-Facilic profile that protects each named health check. And there are some awfully named SDSF class profiles for other panel objects. And unfortunately, we painted ourselves into a corner 20 odd years ago with this naming standard, where it's ISF XXXX, where XXX is some sort of short name for the panel object, like APF, LNK, or PALM, or whatever. And unfortunately, as we increase the number of panels, and we have increased the number of panels by quite some distance, we're generating out these new row level profiles. Unfortunately, that's the situation we're in, and it's just something that exists at the moment. The upper commands profiles are checked when the action generates a zOS operator command. Okay, and we do that after we do any successful access to the profile covering the row. So we've got to have access to the row first, and then we'll look at what we're trying to generate, the operator command we're trying to issue, and then we'll do the check against the opera commands profile there as well. So let's go through 3 examples of what happens when you issue an action character. So we've got this user ID called Fred, and he types H in SDSF to get to the held output queue for the JES2 subsystem called JES2. He then issues a P command against some JES job ID, and the job name is bowling on a node called the Bedrock. Okay, and that job apparently is owned by a user called Barney. So the P action on the row, that's going to try to change something, delete something, so he's going to need alter access. That row, because its output is protected by a JES spool profile. And we also have an opera commands profile involved, because if we, under the covers, SDSF is going to build the operator command that does the thing that he wants to do. So this is therefore the sequence of the 3 SAF checks that we're going to make. First of all, we're going to check, can Fred get on the held output display? So we're going to do a check for the ISF command.dsp.held.jes2 in the SDSF class. Then, because he's trying to do some sort of alter change to that row, he needs alter access to the JES spool profile that covers that sysout. So it's going to be node name, .owner, .job name, .job ID, whatever qualifiers follow after that. And he's also going to need update access to the opera commands profile, jes2.cancel.batout. So what would happen here if this guy just knew the JES command that he wanted to issue, and he sort of cut and pasted that and did a slash? What would happen there is the MVS would just see that command, and the only thing he would need would be update access to the opera commands profile, jes2.cancel. So there's a value add here. The first 2 checks that are value add within the SDSF product. Going forward, example number 2. So user ID Fred again, he types NA on his system called Wilma to show the network activity, and then he types a DN beside the row for the TN32 job name to display the connections. So the DN action requires read, as it's a display style. The row is protected by an SDSF class profile, ISF netact.qualifiers. And there's going to be an opera commands profile check as the DM action generates an operator command. So following that is the sequence of SAF checks that we make. So again, the read access to the SDSF class profile required to get into the NA panel. He's going to need read access to that row object, which is isfnact.tn3270. And then he's going to need read access to the opera commands profile, mvs.display.tcp/IP. Number 3, last example, this user ID Fred types CK, again on system Wilma, to show the health checks, and then types DS against the ASM local slot usage check to display its status. So the DS action here is going to require read, as again, it's a display style request. And this time the row is printed by an X-Facilic class profile. It's a health check, hzs.qualifiers. And again, we're issuing an operator command, so we're going to do an opera commands profile check as well. And the sequence here is read access to see if it can go into the panel. There's a read access check for the X-Facilic profile. And then he needs update access for the opera commands profile, because even though he's doing what we think is a display, under the covers, it's a modify. It's a modify of a started task to do the display. So that's update access to mvs.modify.stc. the name of the health check. Okay. Overtyping values on rows. Okay, so we've covered going into a panel. We've covered taking an action, typing something in the MP column. But you're also in SDSF on various panels, you can overtype a column. but you can only overtype a column value if you have access, update access to a profile called isfattr.type.column. Okay, type displays the panel row object, and the column is the internal column name, not the title, the internal column name. If you want to see those, just issue the collh command on any SDSF panel, and you'll see a list of all the internal column names that we use, the same ones that you would use if you were programming SDSF reps. So this SAF check is performed when the column first becomes visible in the display. Some of our displays are 10s, 20, 30, 40 columns wide. So we only do the check when the column appears on the display, and it must be fully visible. So both the left and right bounds of the column must be visible on the screen. And if the access is allowed, we'll change the screen attributes to allow you to actually type over that column. If the access is denied or the column is only partly visible, it'll just be an output only attributes. So once that valid overtype value is detected, and there is some validation to see what type, but once we have that, then basically it falls through the sequence that we described for doing an MP. So it goes through the same sort of things. Now, is there an object row profile? Are we doing an operator command? Then we have to protect that. We have to check the upper commands profile. So it's exactly the same process as if we were typing an action. Okay, so some fundamental things about controlling the scope of the data that we show on the SDSF panels, because this is used quite a lot, especially on the general user case, where you say, well, I don't want you seeing what else is running on the system. I want to keep you ring-fenced exactly where you are. So the first way that we do this is the prefix command, and this allows or not your ability to alter masking that's applied to the job name that's in the fixed field. It's in the field that doesn't move if you do a scroll of horizontal scroll. And this applies to the queue panels and active jobs, so DA and all the JES queue panels. Okay? And in order for a user to change the prefix that's currently applied, they actually need read access to an SDSF class profile called isf command.filter.prefix. And if they don't have access to that profile, then they cannot change their prefix. In the same way, owner. Okay, so owner is it's the user ID that owns the job or the output. It works in a very similar fashion to prefix, and it has its own profile. So you need read access to isf command.filter. And again, if you don't have read access to that, you cannot change the owner. And the same goes with the dest command as well, the output destination. So we have another SDSF class profile, isf command.filter.dest. You need read access in order to issue the dest command and change the destination. Now, why do we do this? Well, if you carefully define the defaults for various SDSF users, you can keep them ring-fenced inside their own prefix owner and destination scope. Okay? So you can safeguard them, and you can say, right, okay, you can only see on the queue panels on their standard things like ST, DA, H, OS, and I. You can only see the jobs we want you to see. Okay. And if they don't have access to issue the prefix owner or dest command, they can't change it. So they're kept within their ring fence. You can use set display on, and any user can issue that command, and it shows the current settings of prefix owner and dest to be shown just above the column titles. And as a systems program administrator, you can ring fence them by using various keywords on group. There's the idest keyword, there's the owner keyword, and there's the prefix keyword. So if they go into that SDSF group, then you can hard code in the defaults to be used for owner and prefix. And if they haven't got staff access to those commands, that's where they stay. Another thing that comes out from trying to convert from non-staff security to staff security is a rather useful facility going back in history. There's a NTBL, NTBLent statements within ISF PRM that allow some sort of specification of a name table using substring masking. So you can define these entries where it's a second character and these letters for this letter, things like that. And then when you specify those on the IDSP or I command keywords on the SDSF group statements, the members of that group can have authority to browse or take actions against jobs that match these end tables. Now, that isn't easily done inside standard JES-spool profiles. And this was a little bit of a sticking point for quite some time, but recently we've come up with a way that you can achieve sort of equivalent functionality by using RACF variables. So there is a class called RACF vars, and inside the RACF vars, you can create profiles that start with an ampersand and followed by up to 7 characters. And then you can use the add mem function of ralter to add entries to these RACF vars profiles. There's an example here where I'm adding a member called asterisk kits asterisk to a RACF variable called ISF job 1. Okay, and after I've done all this and they're rack listed and you've refreshed, you can then define a JES-spool profile, and then you can use that RACF variable as a qualifier. Okay, so what I'm doing here, N1 or the node, and then I'm using ISF UID. It's another RACF variable that I've set up, and then I've got ISF job 1, and that may have 5, 6, 100 members of various job name masks within there. And so what actually happens is that when that JES-spool profile is rack listed, inside the rack list cache, it will go through and construct extensions, look-asides to that profile. So it can do variable replacement during the authority check. So that allows you to have one profile covering multiple jobs, which means that if people move between departments and they want to have access to various groups, departments, all you have to do is just connect them to add their member to their UID table, or put them into a group that already has access to these RACF vars variable profiles. So it doesn't mean you have to keep adding JES-spool profiles every time someone moves groups. Okay, some more advanced functions. I'll quickly get through this. We've got about another 15, 20 minutes, I think. Cross-system data access. So there's a sysname command, and it allows the user to access data from one or more systems in the sysplex. And you can use masking characters inside the parameter. It's based on the zOS system name. And it actually under the covers causes SDSF to send XCF messages from the local SDSF org server to other SDSF address spaces in the sysplex. And responses are then collected from all the responding systems and presented locally to the user. In order to do this, you need read access to the SDSF class profile, isf command.filter.sysname. Otherwise, you just get the default. And that will be confined to the local system. Destination operator authority. So this is there to, it's sometimes deemed impractical to commit operators or systems programmers to every single JES-spool class profile so that they can view or manage output in support cases and things like that. So historically, SDSF has provided this ability to find users with authority based on the destination for the output rather than the owner and job name. And this is where this term comes up of destination operator. To be a destination operator, the user ID must have read access to an SDSF class profile, isf name of the JES2 subsystem. And if they want to have full management of any output on there, they need auto access to another SDSF class profile, isf name, or just read access if they just need to be able to browse that authority. Under the covers, what we're doing here, there is a browse token that we pass to JES, and we populate that with the network receiver ID. And then when SAF authority check is made by JES for JES-spool, it uses this receiver keyword on the rack group, and we add a log string for all auditing purposes to let the security product know that it's being done because of this reason before, because this guy has destination operator authority. Foreign address-based data access. So some of the more modern SDSF commands require cross-memory access to other address spaces that are not necessarily under SDSF, like task control or the user control. So that sort of is the term foreign address space. It's an address space that has no idea that I'm really looking at it. And the data is typically gathered by scheduling an SRB into that ASOB. So the ability to do that is protected by an SDSF class profile, ISF job, .type, .owner, .jobname, .sysname, and you need read access. If we can't work out the owner of that address space, and sometimes you can't, you know, if it's a system address space, sometimes they don't have an owner associated with them, we will use 8+. And the types, the typical things here, like there's DD name for the JDD action, or there's storage for JM and JMO, and the mem command, tasks for JT and things like that. So we will do a check against that profile to see if you're actually allowed to go snooping around inside that ASID. Another thing that you might want to consider is allowing someone to do an action in SDSF that issues an operator command that they might not be able to do natively outside of SDSF control. And so the solution to this is to have a when console on the permit command, the upper commands class profile, for example, there, that I'm allowing this ID thread to do a JS2 cancel bat out only when console is SDSF. So when we do the operator commands under the covers, we pass it the console name of SDSF. So you need the console class to be active and the SDSF console defined as a profile within that class. Issuing operator commands generally, and this is another important thing that we want people to be aware of, is that when someone just does a slash command or the ISF slash function in Rex, the only thing we do is check that you have read access to SDSF class prepper called isfopper.system. So that's the only thing. If you have read access to that profile, you are allowed to issue the slash command. And just also bear in mind, some people still think that the only way you issue operator commands to MVS is via SDSF. There are other authorized programs that can do this, including automated operations and things like that, which is a thing you need to consider if you haven't activated the opera commands profile, opera commands class. So the command text that follows the slash is passed directly to zOS to process. We don't make any attempt to parse the freeform text or do any sort of internal opera commands authority checks. And also, when console SDSF does not apply, it is purely freeform text that the user has decided to send to the operating system. So the BCP, MVS, will issue its own SAF opera commands check when it gets the command passed to it, and it will make a decision based on that. It's sort of like we don't really have any control over that decision. The big thing that you need to keep in mind for 2.5, especially if you're migrating from a down level and you are doing going from a mixed SAF and non-SAF environment to a SAF only, is the no decision situation. Okay, so just level set SAF authority check can have basically 3 basic return codes. Return code 0, the user is permitted to the profile that covers the resource. Return code 8, he has no permission to do the profile covering resource. Or this weird return code equals 4, where no decision can be made by the security product. And there's a couple of reasons why that might happen. The class might not be active that covers that profile. The class is active but hasn't been rack listed, and we need a rack listed profile in certain circumstances. Class is active perhaps and rack listed if applicable, but we can't find a matching profile in the listable profiles within that class, and that could happen when there's no catch-all profile. Asterisk, or just asterisk, that been defined with some site-defined UAC value. So this has real implications for us when you're going from a legacy environment where we had a non-Ceph case. Because what would happen in a non-Ceph case is we get a return code 4, and then we would fall back to some security specifications in ISF PRMXX or your old ISF Palms load module. We no longer do that. We don't fall back to internal security. So we have to know what we're going to do. We can't just sort of say, well, we can't make a decision. We have to make a decision. So there is a connect statement, and it has a keyword called awk_saf in ISF PRMXX, and that sort of has a value of fail RC4 or no fail RC4. So if we have fail RC4 in effect, it converts all RC4s from SAF into an RC8, right? And that's the default. So we will deny, if we can't make a decision, we will deny access. But you can use no fail RC4 to help convert from your return code 4s from SAF into a return code 0. And that might be handy during initial migration situations or testing systems where you just need to get the damn thing to work. But we also recommend that you run with fail RC4. So it's all quite complicated, and seeing the process, the flow, and exactly how many resource checks get made for any one thing can be a little bit daunting. So we tried to add some functionality to the product to make this a little clearer. So this chapter is using SDSF to understand SDSF security. So there's a new command in 2.5 called CMDH, command help. So you can just type in command help on the panel, and it'll list all the primary commands that you can type, and their dependencies, if they need SDSF forks, when they were introduced. But we also say if there's a protecting profile, we'll put the class and the resource name that covers that command. So this can help you from the product just see exactly what profile you need to even issue the command in the first place. There are some commands that aren't protected, things like help and command H and call H itself, all those sort of help basic user interface commands, we don't protect those. Once you get onto a PAL, you might want to say, well, what's the attributes of the various actions? So there's an act H command that you can do, and then it lists all the actions and the authority level that you need, and the class that it will check against, and the profile resource name that it uses as well. Wherever you see lowercase values here in that resource field, that means there's some sort of variable replacement that's taking care under the covers to present the profile to the SAF check. So things like the JES subsystem name or the job name, things like that. The col H, over top of the columns, if you type col H, over top of columns will also include the class and resource that protects the overtypable ability. You see here ISF attr.job. Field description. So easy to say what you would need to do overtypes on that panel. The security trace. So this is the really handy. So this is a security specific trace, and it's independent of the normal SDSF trace. And it can be used to see all SAF checks issued by the SDSF product. Okay? And your trace output is sent to your ulog by default. So you can issue a set command, set trace on, and set trace off, so on and off. Or you can use set trace WTP, which is going to make the security trace messages come out as write to programmer style WTOs instead of going to ulog. Most people tend to send it to ulog. There are some special DD names that we will look for, especially if you're trying to trace security calls made during initialization, where you can't go in and type in set trace on. So there's ISF sectr, which is equivalent to set trace on, and ISF sectw, which is equivalent to set trace WTP. So you can then see all the security calls that are made during initialization. This is what the security trace output looks like. So you can see here, we have a sequence of messages where access is allowed, SAF return code, we document the access intent, the class, the resource, we have a requester label. So internally we know where we're actually making that check on whose behalf. So you can see here all these various things that are going on behind the scenes in order to make a decision. And when access is denied, you will see a non-zero SAF return code here and a label saying access denied. So it really can help. We also have a health check, and it's the SSF class active health check. Primarily was there just to verify that the class was active or not, but we've enhanced it recently to produce a report on SSF resources and how the security decision is derived. Okay? So you get this report and it'll say, right, okay, you're either going to be covered by whatever SAF return code is, which is great, this is what you want, or we couldn't find a covering profile and access will be denied using to AUX-SAF fail RC4 that you've got specified in ISF PRMXX, or you have no fail RC4 because of the same reason, but you're using AUX-SAF no fail RC4. And what we say, it's always very, very wise to verify all entries that do not have SAF RC to ensure that you do not have exposures due to missing or incorrectly typed profiles. So you really want that report to run and everything to be SAF RC. Here's an example of the health check output. On the left-hand side is the header where we check if the class is active. There's some descriptions there on what the columns mean. And then there's lots of these rows where we document the decision, the access attempted, and the resource that we are testing. You can use this health check to see your current status. Now, just because it ends return code 0 doesn't mean you're done. We'd always advise you to review this report carefully and make sure that you've got everything covered. You don't want to see fail RC4 or no fail RC4 reports within this health check. Okay, so that's the end of the presentation. Session feedback, please, if you can, it'd be great. Any ending questions, I'm happy to answer. Joe, is there
nothing in the chat just yet, Rob? Last chance, Saloon. Any questions for Rob? Thanks, by the way, Rob. An incredibly detailed session.
Okay.
Yeah, really interesting. Give it a second or two. Nothing coming through, Rob. Looks like you're off the hook.
Okay, good stuff. No rotten fruit thrown my way.
Yep.
Good.
Okay. I will wrap it up there. Thanks again, Rob. That's it for Large Systems today. We are back on air tomorrow at 10:30 with session 9G, where Dave Clitheroe is going to talk about GDPS. That session just now for Rob was session 9E. Please do not forget to submit your feedback. And with that, I'll bid you a farewell and a wonderful evening wherever you are. Thanks again, everyone.
Thank you. Bye-bye.
Cheers. Bye-bye.